Yo. We are live. We someone and I don't see. मम्मी मेरा फोन बना दूँ मैं बेड पे चला नीचे मम्मी तो खोया तू ना कल मार लगे फोन तो ना मैं चाह रहा हूँ मैं ट्रेन में there might be some tweaks that we need to do to get most out of our passport and zero and again and again connect and we are good to go. Certainly good to go. We will be in a minute. No need to worry here. Certainly not much to worry. So we will continue from where we left off, and it might be from here. I think. Yeah. Yesterday we were able to solve this by best time to buy and sell stocks, and then we would have moved to maximum survivalism. If one can get let's see things. Yeah, we're off to a good start. Also, I wanted to see how to tweak this. I don't range. Response will not have that big of an effect. Like how I want. But where is it? Okay. Fine. There's too much of light. Yeah. Okay. I need to fix this. This fact of the each thing can work with it. So I'm holding my mouse with this hand. As you can see, I've already solved it. Let's see when was it? It was in 2025. So nearly a year ago. We tried to find the best approach for each particular problem, and yeah. So this is our question. Okay, leave this part. So according to question, we are being given an integer array nums. Find the subarray with the largest sum. Return its sum. So not only do we have to find the subarray with the largest suppose its sum, but we also have to return its sum. Also, there is a follow-up. If you have figured the ON solution, try finding another solution using divide and conquer approach, which is more subtle. Uh, as you can see, the length is up to 10 to the power 5, and each of these number can reach 10 to the power 4 or negative 10 to the power 4. So the best solution might be ON solution. How will we actually reach there? If you might have seen here, there is always a hint. This is a cadence algorithm. question. So what actually is Cadeni's algorithm? Cadeni's algorithm says if you're taking some something, let me remove it also. So what is algorithm helps to solve maximum what is actually Cadeni's algorithm? Formally, the task is to find indices I to j which are in a given order and the largest of them is less than n. So the sum of from I to j is taking some of all these values is as large as possible. So if the array contains all negative, then the problem must reveal a maximum subarray. Uh, is subarray is the entire. Okay, non-negative, non. If the array contains non-positive number, non-positive number, then the solution in any subarray of size 1 containing the maximum value of sum. Okay. Several different subarray may have same maximum sum. Application scans the array from 1 to n. This is not the thing I wanted to show you or see myself. And the thing is, when you're going from a point A to B, you have a current sum. Okay, up till a point, there will be a point somewhere here at which your current sum reaches the negative status. What you do, you replace the current sum or you compare it with the current now. So supposedly we are moving from here to there. Currently your sum is minus 2 comma minus 2. This is your current sum. And when you come here, current sum is less than this this number. So now you replace your current sum with 1. Okay. Now again you move forward. Your current sum is not less than this, so you just add it and your value will be minus 2. Then you come here. Okay. Your current sum is less than this, so the current sum will change to 4. 4, then you add minus 1 also because 4 is not less than minus 1. And it will reach sorry 3. Then you add 2 also. 2 will be in there. It will reach 5. Then again it will reach 6. Then there is a minus 5. So are you seeing a problem here? Like we are able to compute the current sum to the maximum degree, but we are not storing it anywhere. So what we do while we are computing this also, we run a separate variable that is our global sum. So global sum will track uh, global maximum. It tracks the maximum of current sum versus global sum. If as we move down here, our global sum will be 6. We also compute the global sum at each iteration. So every time current sum update, global sum update with it. Now that we have reached here, I don't know if you are able to see or not. Honestly, I don't care. Um, we have reached here, we will see the current sum fall to 1. While our global sum is still at 6, we will not replace it. Now, next again, 1 is less than 4, so our global sum will change to 4. This will be the algorithm. The maximum sum will be 6 if we are right. Yeah, 6. Let's try to code it up. So there is a current sum, equals to 0. There is a global sum that is also equal to 0. Now that we are iterating through this for I inputs, current sum equals to maximum and, and global sum equals to max of global sum from current sum. This should be it. Fine. Right? Let's try to submit it. Also, communication wrong. This. Why so? There a logic behind it. We need to open the discussions. I think I might have previously filled on the same thing. Yeah. Even in negative, we need to take this one. What code did I do? The same code. Currently doing. No, not the same. Let's open the discussion tab and here it is. This is okay. Algorithm is only end of the yes, actually, cadence algorithm is also sliding window functions, but you just don't maintain a window, you straight up summit. Let's first see what is the problem here. Let's try to think for a negative minus a minus. Okay, I think it might be how we initialize this. Let's initialize it into the buffer. We will be okay. Okay. Let's add the space. Hopefully, yes. So largest will be, I think, minus one. This, yeah, minus one. Yeah, show the cell. Okay. Counts averages score less than kill. We can do that, but we are following the order here, so I think we should stick to it for the time being. Mm, Product of array expect self. So how it is done? A prefix plus suffix. These here are the name of all the pattern that you should do when or think of when you are doing a question like this. But you can have other method also, like for the previous question. For the previous question also, if we were to do a sliding window approach, we could have still in the question. This is your length of the whole line, and you make a sliding window. Every time you encounter a positive element, something, You calculate the whole sum of this sliding window. And when you're adding a new element, like the current sum, you try to see if the sum of the entire sliding window is less than the current element or more. If it is more than, then you add the next element. Otherwise, you shift your whole sliding window to that particular point and start from there. That is the way you need a dynamic sliding window. You can do it, but that's not the point that we are trying to learn from the problem. But if so given an integer nums, return an array. I have done this question recently, 2 or 3 months back. Return an array also such that answer I is equal to product of all the element nums except nums of I. So, and another thing, the product of any prefix or suffix number is guaranteed to fit in 32-bit integer. So it will be less than 2 to the power 22 minus 1 and greater than, sorry, yeah, greater than negative 2 to the power 22 plus. Uh, can you solve this problem in one extra space? Yeah, we can do if we were to calculate from both sides, but try to see our perspective. And see, what we are tasked to do is, suppose this is our element for which we want to calculate the sum. They want us to multiply these three, all the rest of element and put it here. So what will the multiplication? 12. And for the 3 again, they want us to calculate this 4 and 2, 8. And for the 4 also, they want to calculate the rest. So 6 and 4 1, it will be 2 3 6. That will be 24. So this is answer that we are tasked to find. The thing is, any approach you're currently thinking might work. But when you go to a question that has a zero element in it, like this example, there will be a problem because if you try to take a global variable with the sum of it, you will encounter 0 and 0 and 0 again. So you not be taking a global. You need a prefix sum for that. So you can that way. Yeah.